Hello, my children. Question of the day. Which digit does A end in? What is A's last digit if this thing here holds? Okay, so when we use modulus, we always look for some kind of simplification. So I'll just call this star. Okay, so we know that star modulus 5, since 4 is just 5 minus 1, this is a to the power of 4 plus minus 1 to the power of a. And here, since we have an a in the exponent, we can't really just go through all possible remainders in modulus 5, because that doesn't really, in just 5, it doesn't mean anything. This is plus or minus 1 depending on the if n a is odd or even. But saying that something has a remainder modulus 5 doesn't tell us anything about its evenness. So here, since this is our problem, and this really nicely coincides with the fact that the last digit is just the remainder modulus 10, and modulus 10 is, you can always split that up into some remainder modulus 2 and some remainder modulus 5, because 10 is 2 times 5. So, firstly, we can just look at firstly, we can actually plug in just the remainders of the a, and just look at what we get, because we won't get a number, we won't get an actual remainder, because as said, we can't really do anything about that with just modulus 5. But let's just start anyway. Okay, so we have we'll start with 0 in modulus 5, of course, that is. Then, okay, this thing just disappears, and what we're left with is just minus 1 to the power of a. Okay, great. And with 1, we get 1 to the power of 4, which is just 1. So we get a 1 plus minus 1 to the power of a. And for 2, we get a 2 to the power of 4, that is 16 in modulus 5, that is 1. So we get the same thing. And for 3, what do we get for 3? 3 to the power of 4, it's 3, 9, it's 27, 81. Remainder 5, that is still 1. So we get the same thing. And then for the 4, okay, 4 to the power of 4, that is 4, 16, 64, 256. Which remainder 5 is still 1. So we get the exact same thing here. So as you can see, only 0 is special. So now we can just start. Okay, let's just go back to 0. Is this ever 0? Minus 1 to the power of something, is that ever 0? The answer is no. Never. It cannot be. So, therefore, this never works. A cannot be have a remainder 0, meaning divisible by 5, which means last digit 5 or 0 or 5 cannot be. So then, okay, all of these cases are the same. And then let's just look at, okay, when is this equal to 0? That means that this thing is equal to minus 1, meaning that a is odd. So all of these things imply that a modulus 2, I can't write, 2 is equal to 1. A is odd. And it works for all of those cases. So basically what we get is that, okay, a remainder 5 has to be 1, 2, 3, or 4, and remainder 2 also has to be 1. So let's just, okay, so we have, okay, 1 works because it's obviously gives remainder 1 in both cases. So 1 works, it has to be odd, so let's move on to 3. Does 3 work? 3 works, absolutely. And 5, does 5 work? No, it is very much odd, but it is divisible by 5. We knew this did not work, so 5 does not work, and I've also written it up here. So let's move on to the next odd number, which is 7. Does 7 work? 7 remainder 5 is 2. So yeah, that absolutely works, and it is odd. So we have a 7, and then the same thing with a 9. That is remainder 4, which works. So then it is 9. So this is our answer. For every number ending in a 1, 3, 7, or 9, this property holds. And that was frankly all for me. Hope you liked the problem. Make sure to like and subscribe, and I'll see you some other time. Bye bye.